Hello everyone, I welcome you all to my channel Revealing Concepts. In today's class, we are going to solve problems for the distance formula that we have studied in the previous class. So today we would be specifically saying the mathematical application of the distance formula. Hence, the agenda for today would be solving problems using the distance formula. To recap what we have done in the last class, we started with knowing the representation of a coordinate plane, then how coordinates are being placed on a coordinate plane. We did see that. We saw what does x and y in a coordinate system represent, that is abscissa and ordinate, and later on we moved on to the distance formula. So what is a distance formula? Let's say कि in a two-dimensional coordinate plane or Cartesian plane, if you are asked to find distance between any two random points on the plane, then the formula to calculate the distance between these 2 points is under root of x2 minus x1 the whole square plus y2 minus y1 the whole square, wherein our x1 and y1 are the coordinates of first point and x2 and y2 are the coordinates of the second point. Okay, so in today's class, we would be using this distance formula to calculate these two and one more problem. So let's start with the first question. The first question says that you have to show that these 4 points or these 4 coordinates are the vertices of a square, meaning you have to show that it forms a square. So let us first draw a square. And I'm going to name this square as A, B, C and D, where your A is nothing but 1, 7, B is nothing but 4, 2, C is minus 1, minus 1 and D is minus 4, 4, right? AB, BC, CD and DA, these are nothing but the edges or the sides of this square, and AC and BD, these two are the diagonals of the square. Now, as of now, we don't know whether this is a square or not. Using the given information, I have just drawn a random figure, okay, whose name is ABCD. Since it is a four-sided figure, therefore I would be calling it as quadrilateral ABCD, right? So we have to prove that, or we have to show that these 4 vertices actually form a square. Now, in order to show that these 4 vertices form a square, we are going to use the distance formula. How are we going to use the distance formula? So what I'll be doing is, since we know that this figure has got 4 sides and 2 diagonals, AB, BC, CD and DA. These are the 4 sides. So I would calculate the length of each side of this figure. Now if I want to calculate the length of AB, meaning I have to find out what is the distance between point A and point B. Similarly, if I want to find out the length of BC, I am supposed to calculate the distance between point B and point C. Likewise, I am supposed to calculate the distance between point C and D to calculate the length of the side CD, and finally I would be calculating distance between D and A to get the length of the fourth side, that is DA. Now, after calculating the lengths of each side, I would be seeing whether all 4 sides are equal or not. If all the 4 sides are equal, then I would move on to the part 2 of this question, wherein I would be also finding the lengths of the diagonals in the similar manner. And now all these 4 sides have to be equal with each other, and separately the diagonals have to be equal with each other. If these 2 conditions are satisfied, then we can conclude that the given vertices, the given points are the vertices of a square. So let's move on. So first I am going to calculate distance, or I would say length AB, right? So if I take this to be my x1, this to be my y1, this is x2, and this is y2. So as per the formula, I would be having under root of x2 minus x1 square plus y2 minus y1 square, right? So this is your distance AB, and this is nothing but your distance between A and B, and that is nothing but your length of AB. Now just substitute the values. What is the value of x2? It is 4. What is the value of x1? It is 1. So 4 minus 1 the whole square plus y2 is 2 and y1 is 7 the whole square. Now we all know 4 minus 1 is 3 the whole square plus 2 minus 7 is minus 5 the whole square. Whenever we take the square of a negative number, it is always a positive number, 2 being the even power. So we get the answer as 9 plus 25, which is equal to under root of 34. Now this cannot be simplified further. That is why we get length or distance of AB is under root of 34 units. Since we don't know what is the unit, it is not centimeter, meter, it's not given. So we are going to consider it as root 34 units to be the length of side AB or distance between points A and B. Now similarly, we are going to calculate the distance between B and C, and that is nothing but your length of side BC. So distance BC would be equal to, again the same thing. Now here I would be considering 4 and 2 to be x1 and y1, whereas minus 1 and minus 1 would be x2 and y2. Right? So at a time when you consider 2 points, one has to be x1, y1, the second one has to be x2, y2. And similarly, I'm going to substitute in this formula. Now in exam, you have to write this formula for every step. Here I would be directly now substituting the value instead of writing the entire formula again and again. So now your x2 is nothing but your minus 1 and x1 is 4. So minus 1 minus 4 plus y2 is minus 1 and y1 is 2. Okay, the whole square. So we get under root of minus 1 minus 4 is minus 5. Minus 5 the whole square plus minus 3 the whole square. Right? So that is equal to under root of 25 plus 9, which is equal to under root of 34 units. So again, we got the length of the second side to be root 34 units only. Similarly, we are going to calculate distance CD. Right? Now, here if you see, this is your x1, this is your y1, here this is your x2 and this is your y2. Right? So as per the formula, I will be getting under root of x2, which is minus 4, minus x1, which is minus 1, and minus into minus is plus, so I'll be getting plus the whole square, y2, which is 4, and again since there is minus 1 over here, so minus and minus becomes plus, right? So we get under root of minus 4 plus 1 is minus 3 plus 4 plus 1 is 5 the whole square. So that is nothing but 9 plus 25, which is again equal to root 34 units. Now finally we are going to calculate the length of the fourth side, that is distance AD. So that is again, if you see, now here this is your x1, this is your y1, and again this is your x2, this is your y2. So your x2 is minus 4 minus 1 the whole square plus y2 minus y1, so 4 minus 7 the whole square. So that is under root of minus 5 the whole square plus minus 3 the whole square. So again you would get 25 plus 9, so that is under root of 34 units. So with this we come to the end of step 1, where we calculated the length of all the 4 sides, and we saw that up till now we are successful with verifying that the length of all the 4 sides is same. Okay, so we got AB, BC, CD and AD as root 34 units only. Now we are going to move for the second part, wherein we are going to verify whether the length of the diagonals is also equal or not. So here you are going to calculate distance AC. Okay, so this would be x1, y1. I'll be erasing this, and this would be x2, y2. So again, x2, that is minus 1, x1. Okay, x2 minus x1, so that's minus 1 the whole square plus y2 is minus 1 minus 7. Okay, so x2 minus x1, y2 minus y1. So I'll be getting minus 2 the whole square plus minus 8 the whole square. Then under root of 4 plus 8 ka square is 64. So I get the answer to be 68, under root 68 units. Now let us see what would be the length of BD. So distance BD would be equal to under root of, again this is x1 y1 and this is x2 y2. So x2 minus x1, so I would be having minus 4 the whole square plus y2 minus y1. So 4 minus 2 the whole square. So this is nothing but under root of minus 8 the whole square plus 2 the whole square. So that is again 64 plus 4. So that is under root of 68 units. So now students, if you see, I got all the 4 sides to be of the same length, and the 2 diagonals ka calculation is also the same. This satisfies both the properties of a square. So we got all the 4 sides to be equal and 2 diagonals to be equal. So the final statement that you would be writing in order to conclude that the points are the vertices of a square are. So I'll be erasing this diagram and I'll be writing the conclusion. So this is a conclusion for the answer, right? So you would say that since all the 4 sides are equal and the 2 diagonals are of same length, hence the given points are vertices of a square. This is how we are going to conclude. Pretty simple. Divide it into 2 parts, wherein in the first part you are supposed to show that the 4 sides are equal, and in the second part you have to show that the 4 diagonals are equal. Right? Now we got that yes, the 4 sides are equal, the 2 diagonals are equal, and hence I conclude that it's a square. Now let's move on to the second question. It says that check whether 5 comma minus 2, 6 comma 4, 7 comma minus 2 are the vertices of an isosceles triangle. So here you have been given 3 coordinates and you are being asked whether this forms an isosceles, meaning you have to show that it is an isosceles triangle. So again we are supposed to use the property of an isosceles triangle. So that is why I have written here prerequisites, meaning the knowledge that you should know beforehand, and it is the definition for isosceles triangle, and the other one would be used for the third problem. So as per the definition of an isosceles triangle, we say that a triangle is an isosceles triangle if 2 pairs of its opposite sides are equal. right? They are congruent, or you could say they are of same length, meaning a triangular figure of this kind wherein this side is equal to this side, such a triangle is called as an isosceles triangle. So now first I would be explaining the approach to you, and then in one go we are going to solve this problem on the board. So what we are going to do is we are going to take a random triangle ABC. We are supposed to show that this is an isosceles triangle. So I'll be writing down the coordinates that are given to us over here next to the vertices of the triangle. I'm supposed to calculate the distance of all the three sides and see whether I get either of the two distances equal to each other and the third distance different from these two distances. If that is the case, then we are going to consider that it's an isosceles triangle, because the necessary and sufficient condition for proving any triangle to be an isosceles triangle is its two sides should be equal to each other, right? So let's start. So for our understanding, I'll be drawing the figure. Let's name it as A, B and C. Now, according to the coordinates, A would be 5, -2, B would be 6, 4 and C would be 7, -2. Now let us calculate the length of each side. So distance AB would be equal to under root of x2 minus x1 the whole square plus y2 minus y1 the whole square. So as per the figure, this is your x1, this is your y1, this is your x2, this is your y2. So we get x2 is nothing but 6, x1 is 5 the whole square, plus next we have y2 to be 4 and y1 as -2, so minus and minus becomes plus, and this should be under the root. Now 6 minus 5 is 1 the whole square, plus 4 plus 2 is 6 the whole square. So we get the answer as 1 plus 36, which is equal to under root of 37 units. Now we got the first side to be root 37 units. Now let's calculate distance BC. Again the same formula, but now here this is your x1 and this is your y1, this is your x2 and this is your y2. So as per the distance formula, distance between B and C is x2 minus x1 the whole square plus y2 minus y1 the whole square. So the value for x2 over here is 7 if you see, and x1 is 6. So 7 minus 6 the whole square plus y2 is -2, y1 is -4 the whole square, right? So we get 7 minus 6 is 1 square and this is -6 the whole square. So again we get 1 plus 36 and the entire thing is under the square root. We get answer to be 37 units. Now we got two sides to be equal. Let us see whether the third side comes out to be equal or different. If the third side is different, then we are done with our proof. We are done with our problem that yes, it is an isosceles triangle. But if it is not, it means that there is some gadbad. So we are going to calculate distance AC now. Now in distance AC, this is x1, y1 and this is x2, y2. So as per the formula, x2 that is 7 minus x1 that is 5 plus -2, and now minus into minus is plus. So you get +2, right? And both of them you're going to square, right? So -2 minus into -2, right? So we get 7 minus 5, the answer is 2 the whole square, and 2 and 2 gets cancelled, so we get 0 over here. So this is under root of 4, which is basically 2 units. Now students, when I told you the definition for isosceles triangle, I told you that an isosceles triangle looks something like this, wherein these two sides are equal to each other, and this is so correct also. Now here we don't know how exactly the points are placed. You got it? We have just assumed that the arrangement may be like this. Technically, if you see, I got AB and BC to be equal to each other, meaning the triangle must must ideally look like this. If you see, length AC is different, which is 2 units in this case, and this are equal to each other, that is root 37 and root 37. Now since we don't know how exactly the points are being placed, because we are doing everything on the basis of assumption or visualization, right? So we for our convenience we assume that the triangle is like this. We just have to come up to a conclusion that if two sides are equal and the third length is different, it's an isosceles triangle. Okay, but according to the answers that we got, ideally the figure will look like this. Okay, so how you're supposed to conclude this question? You're going to say that since length AB equals to length BC and the third side is not equal to them, hence it is an isosceles triangle. Basically, you have to conclude that since two sides are of same length and the third one is of different length, hence it is an isosceles triangle. Okay, you can write it in your own manner until and unless it is mathematically correct and even grammatically correct. Okay, so we are done with these two problems. I hope you are thorough with what I have taught you in these two problems. Now let's move on to the third problem. Now let's start with the third problem. What does the question of the third problem lead? It says that determine if the 3 points 1, 5, 2, 3 and minus 2, minus 11 are collinear. You have to determine if they are collinear or not. Okay, so before diving into the question, solving the question basically, I would want you all to know what are collinear points, or when do you say that 3 points are collinear. First of all, collinear means all the 3 points lie in the same straight line. Okay, they lie in the same line. But when exactly do you say that these 3 points are collinear, or what is the necessary and sufficient condition for any 3 points to be collinear? So let's say if you have 3 points A, B and C. So A, B and C, these are 3 points, and if at all you have to show, or if at all you know that they are collinear points, meaning they lie on the same line, same straight line, it means that your AB plus BC, so when you add these two parts, you would get the greater or the higher, the largest length. So this property of collinear points we are going to use in order to solve this problem. What we are going to do is we are going to find out the distance of AB, BC, AC. Now here also we don't know what exactly or how the figure look like, but we are going to calculate 3 distances. Then we are going to add these 2 small distances in order to see whether we get the third distance, the largest one. Okay, so let's start. Now here I would be randomly, I won't be drawing a figure for this one, I would be randomly naming A to be the coordinate 1, 5. So let A equals to 1, 5, then B 2, 3 and C minus 2, minus 11. Now let us calculate distance between A and B, that is distance AB. So as per the distance formula, it is x2 minus x1 the whole square plus y2 minus y1 the whole square. Okay, now this is our x1, this is our x2, this is our y1 and this is our y2. So as per the formula and the given coordinates, we have under root of x2. So we have, I'm so sorry, this is not x1 and x2, this is x1 and y1 and this is x2 and y2, right? So the first coordinate would have an x coordinate, would have a y coordinate. So x1 and y1 and x2 and y2. Okay, so x2 in this case is 2, whereas x1 in this case is 1. So 2 minus 1 the whole square plus y2 over here is 3 and y1 over here is 5. Okay, Now this is equal to 2 minus 1 is 1 the whole square, 3 minus 5 is minus 2 the whole square. So you get under root of 1 plus 4, which is equal to root 5. Now let's calculate length of BC. So distance BC, again, this is your x1, this is your y1, this is your x2, and this is your y2. So this is equal to under root of, again, x2 minus x1, y2 minus y1 ka formula. So x2 is minus 2 and x1 is 2. So minus 2 plus y2 is minus 11 minus y1 is 3 the whole square. So that is equal to under root of minus 2 and minus 2 is minus 4. So minus 4 the whole square plus minus 14 the whole square. So that is equal to under root of 36 plus 196, which is equal to under root of 212 units. So now we have got distance BC to be under root of 212 units. Similarly, we are going to calculate the third length, that is distance AC. So now here C remains x2, y2 only, and now A becomes x1, y1. So again under root of x2 is minus 2 and x1 is 1. So x2 minus x1 the whole square plus y2 is minus 11 and y1 is 5. Okay, so this is equal to minus 3 under root of minus 3 the whole square plus minus 16 the whole square. So that is equal to 9 plus 2, 56. So 9 plus 2, 56 is equal to under root of 265, right? So the third side that you have got is 265 units. So here if you see, let me just verify it once again. Your x2 is minus 2, your x1 is 1, minus 11, minus 5. Okay, right. So this is 256, this is 3, 9 plus 256 is 265. So you have got the third length to be under root of 265. Now here if you see, the first length is root 5 units, second is under root 212 units, the third one is under root 265 units. So out of these three, the largest one is AC. So we are going to consider AC to be the largest part of this line. It means that if you consider AC to be the main line and AB and BC to be its subparts, it means that when you add these two, you should be getting the third length. But when you actually try to add the distance AB with distance BC, which comes out to be under root of 5 plus root 212, this is clearly not equal to root 265, which is not equal to distance AC. So this implies that distance AB plus distance BC is not equal to distance AC, and hence therefore you can say that the given points are not collinear. So since your AB plus BC is not equal to your AC, that is why these 3 points are not collinear. They are non-collinear points. The question here was to determine if the points are collinear or not. So to sum up today's class, we solved 3 problems using the distance formula, wherein in the first problem we showed that the given points are the vertices of a square. In the second problem, again using distance formula, we showed that the given points form an isosceles triangle. In the third one, we were supposed to determine if the points are collinear or not, and finally we got that the points are not collinear because they do not satisfy the conditions for collinear points. So our agenda for today is completed. With this we come to the end of our class. Thank you everyone and see you in the next video.